So here's a video review of this test. I'm going to do it in sections like I did before for the practice test. Number one, the charge when the number of protons equals the number of electrons. We know that protons are positive, and we know that electrons are negative. So if the number of positives is equal to the number of negatives, then the net charge is 0. So when you add, like, suppose there were 5 positives and 5 negatives. If you add those together, you get 0. So the answer here was E, 0. Incidentally, this test may not have everything in the same sequence that your test does, but the questions are all here, so you'll have to look around and find them. Okay, this question number 2 is called the nucleus. The nucleus, you could have had a couple different answers here, but the one that I wanted was dense and positive. So the nucleus has protons in it, and remember when we were doing the pictures of the atoms, the nucleus is a little pinpoint in the center. So it's very, very dense, and it's positive because it's got protons and neutrons. Now the neutrons don't make it dense. The neutrons don't give it a charge, but they do help make it dense. So it has protons and neutrons, but it's very dense and it's positively charged. That's L. I also took M. If you put M on the test, I should have taken that for just plain positive. Okay, the sum of the protons and neutrons. I've gone several times, I've told you that protons plus neutrons equals mass. Sum means add. So this word right here means add. So that would be the mass number, and that's I. A region in space where an electron is found, the position where you'd find an electron, these are like the beds in the pink room or the sunny room. So the beds are called orbitals, and that is choice C, orbital. So if an electron has moved away from the nucleus, remember it's sitting in here, put a little dot in here, the electron moves away from the nucleus, it goes out here somewhere. Then it comes back down. While it is at its higher energy than normal, it's excited. We call that an excited electron. That's A. The center of the atom, I think we all know, is the nucleus. So the nucleus is the center. That's O. The number of cycles per second, that's related to energy. It has to do with the wavelength. Remember we had this wave that we did in class? And the number of times it goes up and down, up and down, up and down like that, that's called the number of cycles per second. That's called the frequency. The frequency, how often it goes, how many times it goes up and down through a complete cycle in a given amount of time. All right, the subatomic means smaller than the atom. There were 3 subatomic particles, protons, neutrons, and electrons. The ones that did not have a charge were neutrons. So that would have been choice H. Protons, neutrons, and electrons. The one with a negative charge is electrons. So that would have been F. A positive subatomic particle, protons, neutrons, and electrons, that'd be protons. And I might mention that if I changed it on the retake to a neutral subatomic particle with a mass of 1 AMU, it's still a neutron. Protons and neutrons both have a mass of 1 atomic mass unit. They both have a mass of 1. Electrons have a mass of 0. So the positive one is the proton, and that would be choice P. Okay, a product of radioactive decay, 2 protons and 2 neutrons. This one we talked about if I was a radioactive nucleus, I was throwing things across the room just kind of randomly. One of the things I could throw would be an alpha particle, and that's this particle, J. Each color has a specific wavelength. And so the wavelengths are here to here, or from here to here. Which one of these, watch my pen. Here's this one. Here's this one. Which one do you think is taking more energy to draw? The one with the shorter wavelength. Okay, so wavelength was choice K. Electrons lose this when they fall. They've been excited, they moved away from the nucleus, they come back down. When they come back down, they lose energy. So that would be energy. That was related to the flame test lab. Okay, these words describe an electron that's in its normal unexcited position. It's in its ground state. When it's not excited, we call it the ground state. That's in. And the charge on a proton we know is positive from earlier discussion. So positive is M. And then the charge on an electron would be negative. Negative is choice D. Okay, so that's it for the matching section of the test.